name is Dr. Esther Trufan, and in this experiment, we're going to make popcorn. Yes, the popcorn that you could eat if you were not in a chemistry lab. But the purpose of this experiment is to determine the pressure that the water vapor can build inside the kernel that will cause your popcorn to pop. So for this experiment, we're going to need quite a bit of equipment and a little bit of popcorn. The first thing that we're going to need is a scale, a 10 milliliter graduated cylinder. We're going to need a 250 milliliter Erlenmeyer. We'll need a pipette. We'll need a wire mesh, a source of heat, a hot plate, some paper towels. And then for our chemicals for today, we'll need some oil. And I already poured out a milliliter into a small beaker. We'll need some popcorn. And I already sampled 25 kernels into a little beaker. And then finally, we're going to need a small amount of water because we're going to measure the volume of the popcorn kernels by displacement inside the 10 milliliter graduated cylinder. So let's get started. The first measurement for today is going to involve recording the volume of our popcorn kernels. The first thing that we need to do is add anywhere between 4 and 6 milliliters of water inside our 10 milliliter graduated cylinder. The amount you add is not important, but what is crucial is recording the volume that you have in there as precisely as you can. So in this case, I have exactly 5.48 milliliters of water. Now I'm going to add 25 kernels of popcorn to it. The most important part here is to have all our popcorn kernels submerged. And if there are any kind of bubbles forming, we need to find a way to get rid of them. And a little bit of mixing, shaking, and tapping usually does the trick. The combined volume of the water and the popcorn kernels in this case is 8.38 milliliters. For the next step, we need to extract our popcorn kernels. The easiest way to do that is to remove the water first. And usually the popcorn kernels are sticky, but if one of them escapes, we'll just retrieve it later. Next, we're going to use some paper towels to transfer our popcorn kernels onto it. Sometimes some gentle or not so gentle tapping is enough, and sometimes you may need a spatula to scoop it out. We're going to retrieve our escaped popcorn kernel from the water and have it join the others. And now we're going to make sure that all of them are dabbed completely dry. Now that our popcorn kernels are dry, we can move on to the next step, which is weighing the mass of the popcorn kernels. For that, we're going to need a scale. And the first thing we do is turn on our scale until it goes to 0.00. The next step is placing our 250 milliliter Erlenmeyer flask on it and recording its mass, which is 117.50 grams. Next, we're going to carefully transfer all our cleaned and dried popcorn kernels inside the Erlenmeyer. And if one of them runs away, we just go after it. When all of them are placed inside the Erlenmeyer, we weigh it again, and the difference will give us the mass of the popcorn kernels. The new mass is 121.55 grams. Next, and before we are ready to pop, the popcorn that is, we're going to pull a couple drops worth of oil inside our dropper, and then transfer 2 or 3 drops inside our Erlenmeyer. This is a very small amount, so the mass is going to be rather small as well, but we need to record it regardless. The new mass is 121.61 grams. Before we can start the popping, it is important that all the kernels are coated in the oil that we're using. So a little bit of swirling, and there are some benefits to swirling versus using a stirring rod, and that is we don't accidentally remove any material from our container. So we have our popcorn kernels coated in oil, and in this case we're using canola oil, which has a boiling point of about 400 Fahrenheit, which we need to convert to Celsius and then Kelvin before we can use it in our calculations. Now that we are done, we can set our scale aside temporarily, bring in our hot plate, place our Erlenmeyer on top of the hot plate, and to avoid any of the popcorn escaping, we take our wire mesh and place it on top. And the rest, just like at home, is waiting. All our popcorn kernels have popped, and we have quite a bit more space occupied by the popped kernels. The Erlenmeyer is a little hot, so we always want to place it either on a wire mesh or some kind of surface that does not have any kind of water droplets on it. And the other thing that we will notice for this experiment is that we have quite a bit of water condensation on the cone of the Erlenmeyer, and that water is water that has escaped from the kernels, but did not escape from the container yet. So we want to dry that and remove it so that it doesn't go back. So we fold some of the paper towel and gently wipe the inside of the Erlenmeyer to remove all those water droplets. And again, you want to be careful because the Erlenmeyer is quite hot. And ideally, you want to wait a couple minutes for it to cool down enough so that it can be easily handled. And as we wait, we can remind ourselves of the things that we need to collect in terms of data from this experiment. The first and most important thing is the volume of the popcorn kernels. In that case, we determined the volume of the popcorn kernels by displacement of the water from the 10 milliliter graduated cylinder. The second is the temperature. The temperature is going to be determined by the boiling point of the oil that was used to coat the popcorn kernels. So if you're using canola oil, as I did, the boiling point is approximately 400 Fahrenheit, which in order to use in the ideal gas law calculation, we need to convert into Kelvin. So we have volume and we have temperature. The next thing that we need to determine is the number of moles of water that escaped from our system. To get the number of moles, we needed to know the mass of our Erlenmeyer with the popcorn kernels before the popping, and we'll need to find out the mass after the popping. The difference between the two is going to be the water vapor that escaped and we wiped off from the Erlenmeyer. From these three properties and the ideal gas constant, we can determine the pressure that had to build up inside the popcorn kernel from the evaporated water vapor that would cause the kernels to burst and give us what we enjoy as popcorn and not the crunchy kernels that were before. So now that our Erlenmeyer is sufficiently cool to the touch, we can move on to our final measurement, and that is the mass of the popped corn. We turn on the scale, get it to 0.00, place our Erlenmeyer with the popcorns inside, and we record our final mass, which is 120.95 grams. And with that, our experiment is complete. Don't eat the popcorn because we made it in the lab, but make it at home and enjoy it.